morning children, and welcome back to chemistry class. Today we are going to study about the metallurgy of silver, and the process of the metallurgy of silver is done by cyanide process. Okay, so what is the ore used over here for the metallurgy of silver? We use silver glance, or what we say as argentite. Okay, argentite, and the formula is what? Ag2S. Then we move to concentration. Since this is a sulfide ore, so concentration method chosen over here will be by froth flotation method. Okay, then let us understand the cyanide treatment over here. The cyanide treatment. So the concentrated ore, it is treated with dilute solution of sodium cyanide, and this mixture is continuously agitated by the current of air. That is Ag2S, that is the ore, your argentite or silver glance, to which we add dilute sodium cyanide. Sodium cyanide, which is dilute, right? What do we observe? We find sodium argentocyanide forming, which is a soluble complex, that is NaAgCN whole twice plus Na2S. Okay, now this sodium sulfide, as I told you, the mixture, it is continuously agitated by the current of air. So this sodium sulfide that is formed, it combines with oxygen and the water, and hence forms sodium sulfate plus sodium hydroxide plus sulfur is given out. Okay, now next what we do? We do the precipitation of silver. So precipitation of silver. This is one process. Cyanide treatment we understood, right? So how the precipitation of silver takes place? Silver is precipitated from the complex salt, that is sodium argentocyanide. By how? By adding more electropositive metal, that could be zinc. So over here, 2 parts of sodium argentocyanide, when it is treated with, what did I tell you? More electropositive metal, that is zinc. It is going to give us sodium tetracyanozincate, that is Na2ZnCN4. What is the name of this? Sodium tetracyanozincate 2. Okay, the name is sodium tetracyanozincate 2, right? And what are we precipitating? Precipitation of silver takes place over here. 2 parts of silver is formed over here. Now next we move to the, what have we obtained? After obtaining this silver metal, we move for the purification of silver. Okay, the purification of silver. So how is silver purified? By the process of electrolytic refining. By electrolytic refining, right? So now let's talk about the purification of silver, which, as I told you, it is done by electrolytic refining. Okay, so your impure silver is what? Your cathode, right? Then your pure silver rod is your anode, and your electrolyte, what is your electrolyte? Electrolyte is your silver nitrate plus 1% dilute HNO3. Now why do we use 1% dilute HNO3? Because it enhances conductivity. Okay, so what do we observe at cathode and what do we observe at anode? So let's see over here. At cathode, the silver ion, it is going to accept one electron and deposition of silver will take place. Where? At cathode, and this is now 99.9% pure silver that we have obtained here. Now what happens at anode? Because my anode is made up of pure silver, so silver is going to lose one electron and continuously release silver ions in the electrolyte. I hope the metallurgy of silver is also very clear to you. Now let us also understand the extraction of the silver from argentiferous lead. Now India does not have much potential source of silver ores, right? So it is also obtained by the byproduct during the extraction of gold and lead. So the lead obtained, remember, the lead obtained from argentiferous galena, it contains about 1% of silver. So there are several processes that are used for the extraction of silver apart from using this ore, that is your argentite. Okay, so what are those two processes? The other two processes by which we can obtain silver could be, one is called as the Parkes process and the other is called as Pattinson's process. Okay, so quickly we will go through these two because they are not very difficult to understand. So let us do firstly the Parkes process, right? So quickly I'll tell you over here that the molten lead and zinc, they are nearly immiscible with one another, right? So molten zinc, it is lighter, it forms the upper layer, and the lead being heavier, it forms the lower layer. Then silver, it is soluble in molten zinc, than it is not soluble in molten lead. So what do we obtain over here? We obtain zinc silver alloy, right? It solidifies earlier than the molten lead, right? Now this zinc being volatile, it can be separated from the silver by the process of distillation. Thus the argentiferous lead is melted and it is mixed with the molten zinc, right? The argentiferous lead is melted and mixed with molten zinc, right? Then what happens? If they are mixed thoroughly, I'm just giving you a flow chart over here. Then silver and your lead, they dissolve in zinc and they rise to the top, forming the upper layer, and molten lead, it forms the lower layer. Okay, then what do? We cool this. After cooling, this zinc silver alloy is formed, right? Zinc silver alloy solidifies, right? While what happens? While your molten lead, which is your lower layer, it is still in its molten state, is still in its molten state, right? Now what? Now this alloy, that is zinc silver alloy, it is skimmed off, right? After the alloy is skimmed off, right? So lead is treated with the fresh molten zinc, and your zinc silver alloy is extracted again, and this process continues. Have you understood this? So the zinc silver alloy, it will be obtained after distillation. Zinc gets distilled and then the silver and some impurity of lead is left behind. After that, the purification of the silver takes place. What is the process for purification of silver? It is called as cupellation process. Okay. So over here, what happens in this refining or cupellation process? The impure silver, it is heated in the cupel. A cupel, it is a bone ash crucible, right? In a laboratory furnace, and the blast of air is passed over that impure silver, right? So lead gets oxidized to lead monoxide, and it is swept away with the current of air, which leaves behind the silver in the cupel. I hope that is very clear to you. So this is the shining silver that is obtained in the cupel, and therefore the process is termed as cupellation process, right? We next come to the second process of obtaining silver by argentiferous lead is your Pattinson's process. The second process was Pattinson's process. So silver obtained from argentiferous lead by Pattinson's process, it is about 2.6%. So silver obtained by this process is how much? 2.6% only. So over here, the silver lead, it forms an eutectic mixture. It forms an eutectic mixture with 2.6% silver melting at 576 Kelvin, right? Further, when this is cooled, then the lead separates out until the concentrated silver rises to 2.6% in the alloy, and the entire mass, it gets solidified. Clear? I hope this is very clear to all of you. Solidifies. So what did I say? That by Pattinson's process we obtain only 2.6% of silver. So over here the silver lead, it forms an eutectic mixture. With what? With 2.6% of silver, which melts at 576 Kelvin. This is first cooled, then the lead separates out until the concentrated silver rises to 2.6% in the alloy, and then the entire mass, it gets solidified. Now from here the lead is removed, right? Then the process over here of melting and cooling is repeated. Okay, so once the process is repeated several times till the entire mass does not get solidified, then that is your silver that is obtained. And again, for purification, what is the process that we obtain over here? Again, your cupellation process. I hope you remember what is cupellation process. It is the impure silver which is heated in the cupel. What is a cupel? As I told you, it is a bone ash crucible which is kept in the laboratory furnace, and the blast of air is passed over it. Over here, what will happen? The lead will get oxidized to lead monoxide and it will be swept out, and what is left behind? We will obtain the shining silver in the cupel. That is the process called as cupellation process. Clear? So with this, we finish off with the chapter. Thank you.